The authority having jurisdiction, abbreviated AHJ, holds sway over electrical installations found on utility poles. The National Electrical Code, often referred to as the NEC, does not extend its jurisdiction to these installations. Instead, the responsibility falls to the local government entity tasked with enforcing the electrical code within its geographical boundaries. In the majority of instances, the local electrical inspector assumes the role of the AHJ for these utility pole installations. The electrical inspector's purview encompasses ensuring that all electrical installations within their designated jurisdiction adhere to the mandates stipulated by the local electrical code. This entails verifying that these installations are secure and adequately shielded from potential hazards, including but not limited to fire and electrocution risks. The AHJ retains the prerogative to mandate that cable and telephone companies procure a permit before commencing the installation of any equipment on utility poles. This permit serves as a mechanism for the AHJ to conduct thorough inspections of the installation, thereby guaranteeing its alignment with the stipulations outlined in the local electrical code. Furthermore, the AHJ may also impose requirements on cable and telephone companies concerning the sustained maintenance of equipment fixed to utility poles, ensuring its continued safe operational condition. This encompasses verifying the proper grounding of equipment and ensuring that all electrical connections remain tightly secured. Should cable and telephone companies fail to adhere to the requirements established by the AHJ, they may be subjected to penalties, which can range from monetary fines to other corrective actions. In summary, the local AHJ exercises jurisdiction over electrical installations situated on utility poles, encompassing meters and panels utilized to power air compressors and various other types of equipment. The AHJ bears the responsibility of ensuring that these installations not only meet the safety standards but also comply fully with the provisions of the local electrical code. Understanding the intricacies of electrical codes and the roles of various authorities is crucial for ensuring safety and compliance in electrical installations. Utility poles, as essential components of the electrical grid and communication networks, demand careful attention to safety regulations and standards. Firstly, it's essential to understand the concept of the authority having jurisdiction. The AHJ is the entity responsible for enforcing electrical codes and standards in a specific area. This authority ensures that electrical installations are safe and compliant with regulations. Secondly, the NEC provides a comprehensive set of guidelines for electrical installations, covering various aspects such as wiring methods, overcurrent protection, grounding, and equipment installation. However, the NEC applicability may vary depending on local regulations and interpretations. Thirdly, utility poles often serve as mounting points for various types of equipment, including transformers, conductors, communication cables, and lighting fixtures. These installations must be designed and installed in accordance with applicable codes and standards to prevent hazards and ensure reliable operation. Firstly, electrical inspectors play a crucial role in verifying compliance with electrical codes. They conduct inspections of electrical installations to identify any violations or safety concerns. Electrical inspectors may also provide guidance and clarification on code requirements. Secondly, permits are often required for electrical work, including installations on utility poles. Permits allow the AHJ to review the proposed work and ensure that it meets applicable codes and standards. The permit process also provides an opportunity for inspections to verify compliance. Thirdly, grounding is a critical aspect of electrical safety. Proper grounding helps to protect against electrical shock and equipment damage. Utility pole installations must be properly grounded in accordance with code requirements. This includes grounding conductors, equipment enclosures, and other metal parts. Firstly, overcurrent protection devices, such as fuses and circuit breakers, are used to protect electrical circuits from overloads and short circuits. These devices must be properly sized and installed to provide adequate protection. Utility pole installations often require overcurrent protection for transformers, conductors, and other equipment. Secondly, wiring methods for utility pole installations must comply with NEC requirements. Conductors must be properly insulated and protected from physical damage. Wiring methods may include the use of conduit, cable trays, or open wiring on insulators. Thirdly, clearance requirements are essential for ensuring safety and preventing contact with energized parts. Minimum clearances must be maintained between conductors, equipment, and other objects. Utility pole installations must comply with clearance requirements to prevent electrical hazards. Firstly, maintenance is crucial for ensuring the continued safe and reliable operation of utility pole installations. Regular inspections and maintenance can identify potential problems before they lead to failures or hazards. Maintenance activities may include tightening connections, replacing damaged equipment, and clearing vegetation. Secondly, documentation is essential for tracking the design, installation, and maintenance of utility pole installations. Accurate records can help to ensure that installations comply with codes and standards and that maintenance is performed as required. Documentation may include drawings, specifications, inspection reports, and maintenance records. Thirdly, training is crucial for personnel who work on utility pole installations. Proper training ensures that workers understand the hazards involved and that they are qualified to perform their tasks safely. Training may cover topics such as electrical safety, climbing techniques, and equipment operation. Firstly, safety regulations are in place to protect workers and the public from electrical hazards. These regulations must be followed at all times when working on utility pole installations. Safety regulations may include requirements for personal protective equipment, lockout/tagout procedures, and safe work practices. Secondly, emergency procedures should be established to address potential electrical incidents. These procedures should include steps for responding to electrical shocks, fires, and other emergencies. Emergency procedures should be communicated to all personnel who work on utility pole installations. Thirdly, coordination with other utilities is essential when working on utility poles. Communication and coordination can help to prevent conflicts and ensure that work is performed safely. Utilities may need to coordinate outages, clearances, and other activities to minimize disruptions and ensure safety. Firstly, electrical codes and standards are constantly evolving to address new technologies and safety concerns. Staying up to date with the latest requirements is essential for ensuring compliance and safety. Electrical professionals should participate in continuing education and professional development activities to stay informed. Secondly, emerging technologies, such as smart grid systems and distributed generation, are impacting utility pole installations. These technologies require new approaches to design, installation, and maintenance. Electrical professionals must be prepared to adapt to these changes and to implement new technologies safely and effectively. Thirdly, sustainability is becoming an increasingly important consideration in utility pole installations. Designing and operating installations in a sustainable manner can help to reduce environmental impacts and to conserve resources. Sustainability measures may include using energy-efficient equipment, reducing waste, and minimizing the use of hazardous materials. Firstly, risk assessment is a crucial component of safety management for utility pole installations. A thorough risk assessment identifies potential hazards and evaluates the likelihood and severity of potential incidents. This assessment then informs the development of appropriate safety measures and procedures. Secondly, safety audits and inspections are essential for verifying the effectiveness of safety management systems. Regular audits and inspections can identify weaknesses in safety procedures and ensure that employees are following established protocols. These audits should be conducted by qualified personnel and should cover all aspects of utility pole installations. Thirdly, continuous improvement is an integral part of an effective safety culture. By continuously monitoring safety performance, identifying areas for improvement, and implementing corrective actions, organizations can create a safer working environment for their employees and the public. Continuous improvement initiatives may include employee feedback programs, safety training enhancements, and equipment upgrades. Firstly, proper material selection is paramount in ensuring the long-term reliability and safety of utility pole installations. Materials used in these installations must be able to withstand harsh environmental conditions, including extreme temperatures, moisture, and exposure to ultraviolet radiation. Additionally, materials should be corrosion resistant and able to withstand mechanical stresses. Secondly, quality control measures are essential throughout the design, procurement, and construction phases of utility pole installations. These measures ensure that materials and equipment meet specified standards and that installations are performed according to industry best practices. Quality control procedures may include material testing, inspections, and documentation reviews. Thirdly, proper installation techniques are crucial for ensuring the structural integrity and electrical safety of utility pole installations. Installations should be performed by qualified personnel who are trained in proper techniques and safety procedures. This includes ensuring that poles are properly grounded, conductors are securely fastened, and equipment is properly mounted. Firstly, regular inspections are essential for identifying potential problems before they lead to failures or hazards. Inspections should be conducted on a routine basis and should cover all aspects of the installation, including poles, conductors, equipment, and grounding systems. Inspection findings should be documented and promptly addressed. Secondly, preventive maintenance is crucial for extending the lifespan of utility pole installations and preventing costly repairs. Preventive maintenance activities may include tightening connections, replacing worn or damaged components, and clearing vegetation around poles. Preventive maintenance schedules should be tailored to the specific needs of the installation and should be based on manufacturer recommendations and industry best practices. Thirdly, corrective maintenance is necessary to address problems that are identified during inspections or preventive maintenance activities. Corrective maintenance may involve repairing damaged components, replacing defective equipment, or correcting installation errors. Corrective maintenance should be performed promptly and effectively to prevent further damage or hazards. Firstly, adequate documentation is essential for maintaining a comprehensive record of utility pole installations. Documentation should include design drawings, specifications, inspection reports, maintenance records, and repair logs. This documentation is invaluable for troubleshooting problems, planning maintenance activities, and ensuring compliance with regulatory requirements. Secondly, data management systems are increasingly being used to manage information about utility pole installations. These systems allow utilities to track the location, condition, and maintenance history of each pole in their network. Data management systems can improve efficiency, reduce costs, and enhance safety. Thirdly, geographic information systems are used to map the location of utility poles and other infrastructure assets. Geographic information systems integration can provide a visual representation of the network and can facilitate planning, maintenance, and emergency response activities. Firstly, standardization is crucial for ensuring consistency and interoperability in utility pole installations. Standardizing components, installation techniques, and maintenance procedures can reduce costs, improve efficiency, and enhance safety. Standardization efforts should involve collaboration among utilities, manufacturers, and industry organizations. Secondly, industry best practices provide guidance on how to design, install, and maintain utility pole installations in a safe and reliable manner. Industry best practices are developed by experienced professionals and are based on lessons learned from real-world experiences. Utilities should adopt industry best practices to improve their operations and reduce risks. Thirdly, collaboration and knowledge sharing are essential for advancing the state-of-the-art in utility pole technology. Utilities, manufacturers, and research institutions should collaborate to develop new technologies and to share knowledge about best practices. Collaboration can lead to innovation and improved performance. Firstly, cybersecurity is becoming an increasingly important concern for utility pole installations. Protecting the communications networks and control systems that operate these installations from cyber attacks is essential for ensuring grid reliability and security. Cybersecurity measures should include access controls, intrusion detection systems, and data encryption. Secondly, grid modernization initiatives are transforming the way that electricity is generated, transmitted, and distributed. Utility pole installations are playing a key role in grid modernization efforts, as they are being used to deploy smart grid technologies such as advanced metering infrastructure and distributed generation. Thirdly, climate change is impacting utility pole installations in several ways. Extreme weather events such as hurricanes, floods, and wildfires can damage or destroy poles and equipment. Utilities need to adapt their designs and maintenance practices to mitigate the impacts of climate change. Firstly, public awareness is essential for promoting safety around utility pole installations. Educating the public about the hazards of electricity and the importance of staying away from downed power lines can help to prevent accidents. Public awareness campaigns should target both adults and children. Secondly, emergency preparedness is crucial for responding to electrical emergencies. Utilities should have well-defined emergency response plans that outline the steps to be taken in the event of a power outage, downed power line, or other emergency. Emergency response plan should be regularly reviewed and updated. Thirdly, community engagement is important for building trust and support for utility projects. Engaging with the community early in the planning process can help to address concerns and to ensure that projects are implemented in a way that benefits the community. Firstly, training programs should be comprehensive and cover all aspects of utility pole installations, including safety procedures, installation techniques, and maintenance practices. Training programs should be tailored to the specific needs of the workforce and should be regularly updated to reflect changes in technology and regulations. Secondly, certification programs can help to ensure that workers have the knowledge and skills necessary to perform their jobs safely and effectively. Certification programs are typically administered by industry organizations or government agencies. Thirdly, continuing education is essential for maintaining competence and staying up to date with the latest technologies and regulations. Electrical workers should participate in continuing education activities throughout their careers to enhance their knowledge and skills. Firstly, the design of utility pole installations should consider the specific environmental conditions in which they will be located. Factors such as wind load, ice load, and soil conditions should be taken into account to ensure that the installations are structurally sound and able to withstand the elements. Secondly, the selection of materials for utility pole installations should be based on their durability, resistance to corrosion, and ability to withstand environmental stresses. Materials should be chosen to minimize the need for maintenance and to ensure a long service life. Thirdly, the installation of utility pole installations should be performed by qualified personnel who are trained in proper techniques and safety procedures. Installations should be performed in accordance with industry best practices and should be inspected to ensure that they meet all applicable codes and standards. Firstly, the NEC provides specific requirements for the grounding of electrical systems. Grounding helps to protect against electrical shock and equipment damage. Utility pole installations must be properly grounded in accordance with NEC requirements. This includes grounding conductors, equipment enclosures, and other metal parts. Secondly, overcurrent protection devices, such as fuses and circuit breakers, are used to protect electrical circuits from overloads and short circuits. These devices must be properly sized and installed to provide adequate protection. Utility pole installations often require overcurrent protection for transformers, conductors, and other equipment. Thirdly, wiring methods for utility pole installations must comply with NEC requirements. Conductors must be properly insulated and protected from physical damage. Wiring methods may include the use of conduit, cable trays, or open wiring on insulators. Firstly, clearance requirements are essential for ensuring safety and preventing contact with energized parts. Minimum clearances must be maintained between conductors, equipment, and other objects. Utility pole installations must comply with clearance requirements to prevent electrical hazards. Secondly, applicable codes and standards may vary depending on the type of equipment being installed on the utility pole. For example, communication cables may be subject to different requirements than power conductors. It is important to consult the applicable codes and standards to ensure compliance. Thirdly, the AHJ has the authority to interpret and enforce electrical codes and standards. The AHJ may have specific requirements or interpretations that are not explicitly stated in the codes and standards. It is important to consult with the AHJ to ensure compliance. The AHJ may require that the cable and phone companies obtain a permit before installing any equipment on telephone poles. The permit will allow the AHJ to inspect the installation and ensure that it meets the requirements of the local electrical code. The AHJ may also require that the cable and phone companies maintain the equipment on telephone poles in a safe condition. This includes ensuring that the equipment is properly grounded and that all electrical connections are tight and secure. The authority having jurisdiction, or AHJ, holds a critical role in ensuring the safety and code compliance of electrical installations on utility poles. It is essential to understand the AHJ responsibilities and the requirements they enforce to maintain a safe electrical environment.